This is what the evolution of ICT looks like. New ICT technologies, enabled by cloud computing, are creating exciting new user experiences. Order groceries with a swipe of your finger. AI-powered machines predict the success of your business. VR devices can even show you the living spaces of the future. New products, new services, and new business models. This is the new era of ICT. As the world's leading ICT solutions provider, Huawei is ready to listen, share, and contribute to achieve success together with their partners. It's a new win-win ecosystem.
As the video just shows, technology is changing everything.
Together, we can shift the cloud. Together, we can win the future.
Huawei is a leading global information and communications technology (ICT) solutions provider. The company established its Middle East headquarters in the year 2000. Over 60% of employees are locally hired. In the Middle East, Huawei has well-established strategic partnerships with leading companies, operators, and government entities. You are the future. We welcome you to join.
Thank you very much, Sandy, and thank you so much for this brilliant opportunity that young people are having through this academy. Like Sandy has already said, my name is Rupert Charles, and I'm from Makerere University Business School. I'm the director of the ICT Center. Huawei Academy is one of the, we believe as Makerere University Business School that Huawei Academy and having it here, having that center as a Huawei Academy will provide opportunity for especially Ugandans, will give Ugandans opportunity to learn and be able to appreciate these key technologies, and cloud computing is just one of those areas, as I know Sandy will share. It gives a lot of opportunities, especially for skilling. And as you will learn that that the fourth industrial revolution technologies is what we need if we are to be able to make meaningful contribution. They are the skill sets that we need. And that's why as a business school, we look at this as a great opportunity, and we are proud to be to partner with Huawei and to make sure that Ugandans have this opportunity. So I want to thank every person that has taken this opportunity. There are many out there who have not gotten this opportunity, but you making that decision to come and be part of this for the next couple of weeks is a great opportunity. And I want to say that you will not regret this opportunity. You will not regret the knowledge and the skills that you will be able to get, because the future, the skills, the future that you need for the future, these are the ones. And I want to encourage each and every one of you to really take this serious and make sure that you just don't attend, but at the end of the day, we must be able to pick those skill sets that we will practically apply. So from the Makerere University Business School, we want to congratulate all of you who are part of this, and we want to encourage you and that please go ahead. The future belongs to you, and you're the people who will be able to make a difference. And as a school, it's our desire and commit to continuously provide a platform through which many of you will be able to get hands-on and be able to acquire this knowledge. I want to take this opportunity really to launch this cohort. This is not the first cohort. We had a previous cohort the last month, and then this is the second one. we really want to welcome all of you, and we want to take this opportunity to launch this class. And I want to say that you are in the right hands. We believe in our facilitators. We believe in our facilitator right now that is taking you through this, and we want to encourage all of you to do it to the very end. Thank you very much, and may God bless you even as you go through this interesting journey.
Thank you so much, Director Charles, for those remarks. So, we officially begin our class today. Many of you have been asking in our Telegram channel. Some of you have been excited, and some of you have been long waiting for the day to come. And here we are. I want to also emphasize that you have made the right decision. And I also want to recognize a few professionals who are part of this class. They're already placed somewhere. They are doing a given job somewhere. Maybe let me also start with the class rules. I want to mention that kindly keep your microphones muted unless when you want to speak to me. Please kindly keep your microphone muted to enable us communicate with each other. That is one rule. The other rule is that kindly make sure that you attend. And another rule for this class is kindly make sure that you do all the assignments that are given to you. When you attend, also make sure that you take the attendance. We designed a platform for you, a platform to help you practice and to help you get yourself acquainted with a few questions here and there. Kindly also utilize it. After this class, I'll be sharing links to some of the material and some of the platforms you're going to be using, with a brief tutorial guiding you on how to access and register for those platforms. So kindly also make sure that you do the same. So like I've mentioned earlier, let me also re-echo it again. We are going to have 6 chapters in this course. And chapter 1 will be a brief introduction to cloud computing. And chapter 2 will be introduction to compute virtualization. Chapter 3 will be network basics for cloud computing. Chapter 4 will be storage virtualization basics. Chapter 5 will be introduction to virtualization features. And the last chapter, which is chapter 6, will be cloud computing trends. And I want us to have an interactive session. I want you to enjoy the class. These are some of the things I expect from you. But most importantly, I want you to learn and understand these concepts, because they are going to help you not only to pass the exam, but they are going to help you in the different circles of life. For those who are taking this course, some of the prospects of this course are people maybe who are planning to end up becoming cloud compute engineers, or maybe those who have hope to obtain the certificate, the HCIA cloud computing certificate, and operators and maintainers. We have administrators, we have planners, designers, we have IT managers, we have system administrators, we have network administrators. These are some of the target audience that this course usually basically focuses on. And also, maybe for you to be able to take this course, we need you to have a prerequisite of some basic knowledge of IT, how to use a computer, how to click, and also to have some familiarity with the basic knowledge of not necessarily how to operate it, but at least when you know what a server is, what a personal computer is, what is an operating system, just knowing. But worry not, even if you don't know, when we get to that point, we shall be able to explain some of a few concepts. And also, we need you to have some basic familiar of storage, knowing what is a storage, what do I use a flash disk for or a hard disk for. Just basic knowledge. You don't have to have a lot of knowledge. And maybe upon completion of the program, you'll be able to understand what cloud computing is, and you'll be able to clearly describe what cloud computing is. You also understand the history of cloud computing, and you'll be able to list a few use cases of cloud computing. And also, you understand some of the technologies of virtualization. You understand why we need to virtualize some of the different resources available for use, and some of the technologies that they use in virtualization, like KVM, like Fusion Sphere, which is a Huawei solution for virtualization. You'll be able to also describe and explain what virtualization is, like I stated. And also, you will be able to use some of the virtualization tools. You'll be able to create your own environment, and you'll be able to create and play around with virtual machines. And basically, we need to understand that cloud computing is already here, and we need to understand the advantages or the benefits that we are going to get when we choose to embrace cloud computing. There are also other things which we shall be looking at later on, and we shall also get an opportunity to do the labs, or what some people are calling the practicals. Usually what we do, we write to China and they set for us lab environments, because I've also noticed that many of us, or some of us, do not have computers strong enough to support or to create your own lab environment. However, I went ahead and shared the installation guide for those who would wish and would want to set up their own lab environment to do and practice some of those things during their free time. I've shared, or I'll share the softwares so that you can install them. And for those who are having operating systems other than Linux, you will have either to install Linux alongside your preferred operating system, or you can choose to create a virtual machine and install Linux in it, and then go ahead and install those other softwares that are required of you. Okay, so maybe those are the brief introductions. Maybe once again, for those who have just joined the program, my name is Sandy Samuel. I am a certified Huawei instructor at the Huawei ICT Academy, Uganda, placed at the MOOBS Huawei ICT Academy. And this is the HCIA Cloud Computing version 4.0 professional training, which you're going to take for 2 weeks. And after those 2 weeks, you'll be able to do the exam. And if you pass, you'll certify as Huawei recognized cloud computing engineers. Okay. So once again, I welcome you to this class, and let's start with our first chapter for today. And chapter 1, like I said, it's the brief introduction to cloud computing. And we want to try and understand more about cloud computing. People outside of the tech industry, many of them have questions, and sometimes when they come across the term cloud computing, because it has been described in so many different ways. Actually, even when you go to your phones right now or your computer and you type in what is cloud computing, you'll get different answers because of the different kinds of services that are provided by cloud computing. So in this chapter, we are going to try and understand that IT is a fast changing industry. We all agree, isn't it? And cloud computing has been developing rapidly in recent years and has become the foundation of a wide range of major applications. So the major question we are asking in this chapter, what is cloud computing? How has it evolved to what it is today? And this chapter will offer you a brief introduction to the history and the present of cloud computing. I believe even right now, let me first mute some of you. I believe even right now, many of you have got an opportunity to use some of the services offered by cloud computing. If I may ask, you can just maybe drop a message in the chat. Who of you have used any cloud computing service and what was it? Yes, please. Anthony, you're asking if you're allowed to take screenshots. It's okay, you can take the screenshots. So you can just post in the chat who has used any cloud computing service before or anything that you think is related to cloud computing. Okay, someone is telling us, Norman is telling us they have used Google Docs. We see many people have used Firebase, iCloud, Google Drive storage, iCloud, Google Drive, Microsoft Azure, and so on. So yes, we have even today used many of those products. Some of you store your contacts on Google. As you're saving it, you save it on Google. And then whenever you change your device or sign into a new device, your contacts synchronize automatically to your new device. But you are saying, yeah, I store my contact somewhere up in the cloud. If you maybe are using iCloud services. Or some of you have actually used Microsoft 365. Or some of you have used Google Docs like my friend has said. And you are able to edit a document in your browser. You did not install any kind of sophisticated software or instructions for a word processor, but you're able to access the software and you use it in the cloud. So in this chapter, I want to understand, yes, we know those platforms are there, but what is it? Can we be able to understand and explain it? So upon the completion of this course or this chapter, we shall be able to describe what cloud computing is, the history of cloud computing, the different use cases of cloud computing, and also the characteristics of cloud computing. Okay? So, we are saying that cloud computing is already there, and we have all agreed that cloud computing is already here. And we want now to look at some of the solutions that are being offered by Huawei. We have Huawei Cloud here. If you go to www.huawei.cloud.com, you'll actually be able to get onto this platform. And we are seeing it has different modules that Huawei is offering us. Okay? We are seeing different modules, and under compute, we are seeing we can actually set up an elastic cloud server, the ECS, which is scalable on-demand cloud servers. This is also similar to that of AWS offered by Amazon. We are seeing that we can actually have a bare metal server, dedicated physical servers offering excellent performance and data security. We are seeing we have auto scaling. We are seeing we have image management service, and we are also seeing we are having the cloud container engine, and we shall get an opportunity and try to exploit some of these functions. And even later on or during the break, I'll be able to walk you through the console for AWS, the console for GCP, the Google Cloud Platform, and also the console for Microsoft Azure, so that you can get a brief idea of what we are talking about and the different products or services that are offered by the different key players when it comes to cloud computing. Okay? So we have all agreed that cloud computing is already here. And like we said earlier on, some of us have been able to use some of these tools. We have used the backup and restore. You back up your things in the cloud. And actually, when you set up your phone and sign into your new phone, you'll be able to get your data back, but it is saved somewhere in the cloud. Okay? And also, we have used Google Translate somewhere. I don't know if you have used it, but sometimes I've used it when I'm talking to my colleagues from the different regions, and I want to understand what they're trying to mean. I am able to translate any word, but all this is being powered by cloud computing. And some other softwares, this is available, the reader, the cloud reader on Huawei devices. Some of you have used Google Photos, isn't it? where you store your photos to the cloud. And you can actually go on your phone, you can actually do facial recognition, and you're able to filter out only images for a particular contact, and all that is being powered by the cloud. So we want to look at some of the advantages of cloud computing, or sometimes people refer to them as characteristics of cloud computing. And we are seeing that one of the characteristics of cloud computing is on-demand service. This one here, on-demand self-service. So just think about it. Let's use a supermarket as a good example. We have a supermarket. When you enter a supermarket, you go to the different shelves, pick what you want, pick all the items you want as you're putting them inside your cart. Then after, when you're done, you will go to the counter and you just pay and you go away. But ideally, you more or less or sometimes don't need any assistance from the supermarket attendants to help you get what you want or decide what you want. Okay, you just pick what you want because it's on-demand self-service. Or think of it like a buffet where you go to eat food and you have different dishes available to you. And on those dishes, you pick some piece here, you pick another there, you put what you can afford or what you can eat and finish, or what you want, and you actually leave out what you don't need without necessarily having someone to serve you. So even if there's no one standing at the back of the table, you can be able to serve yourself and you get exactly what you need. So that's why we are saying in a supermarket, each consumer chooses the items they need by themselves. Let's say they'll go for a similar goods of the same category and they make choices, they compare the prices, they compare the brands, and they are able to choose everything they need by themselves. Maybe if I let me be loading my console for AWS from Amazon. Just a moment. Okay, just a moment.
Hello, Samuel.
Yes, please.
It's a concern. I was requesting that maybe you mute all of us so that we don't get that feedback. Yes.
All
Later
right,
on, you unmute us. Yeah.
Okay, I'm going to mute all of you, and I'm going to request that all of you should put hand down. But in any event that there's anyone who has something very burning, you can put up your hand, and then I'll also be picking you up. So Robert, I see your hand is up, and Victor, I see your hand is up. Kindly lower it unless when you have something very burning. Okay, thank you for that concern. Okay. So, are you seeing my screen now? So what happens with on-demand self-service, like you see now, since I muted you, I will assume that you are seeing my screen, but you will see that I have different options available to me. And it's entirely up to me to go ahead. This is Amazon Web Services, but I can choose to get an Elastic server. But even as I'm creating a virtual machine within those seconds, I can go ahead and choose. I don't have to call anyone from Amazon and tell them, you know what, I need a server there and then, and I want to install a virtual machine on your server. I don't have to. I just have to go to my console, log in, and then look out for what I need. For example, if I wanted to set up a Red Hat Enterprise Linux server or virtual machine on it, then I'll go ahead and select that. After selecting that, it will load, and then with the different options that are available to me, I'll go and see and look through what I need. How many CPUs do I need? Do I need 4? Do I need 6? Do I need 2? What kind of memory do I need? Do I need 1000 GB? Do I need 500 GB? It entirely depends. What kind of storage do I need? Do I need SSDs? That depends if I'm going to need to make fast reads and writes. And then also I need to determine my network performance. But all this, I am actually not talking to anyone from Amazon. I'm actually doing everything on my own. And I can also go to the different options that are available to me. Even if I wanted just to have a database, a relational database, database service, I could actually go ahead and start it. Okay, I could go ahead and go to the platform, create it, fill in all the instances that I need. And a good thing with all these platforms, they actually give you some free tier accounts or free tier services, which you can use free of charge without actually you having to pay money for those services. So this is on-demand self-service. I can see you raised your hand. I can see Victor and Francis, you raised your hand. What is the issue, Victor? And Francis? What is the issue? I've given you permission to unmute. Kindly lower down your hand if you don't have anything serious that you, because you could be there and you're not hearing, or you're seeing a black screen and you're missing out. So kindly just keep your hand, raise up your hand if you have anything serious that you want to address to me. Francis. Okay, so kindly lower your hand. Okay, let me lower it down for you. And then you will put it up in case you have anything. So this is what we are calling on-demand self-service. Okay, so let us go back to our slide here. And we are saying that one of the advantages of cloud computing is our on-demand self-service, where we have said you just go onto your console or your portal and you select everything that you need for you. But you know, before you select what you need, the prerequisite of on-demand self-service is for the consumer to understand their own needs and know which products can accommodate such needs. Because you can't select what you don't know. If you went into the supermarket and you want, let's say, to cook rice, you already know that you have a need of eating rice and you want to cook it. But what would you need? You need probably to buy rice, you need probably to buy salt, or maybe to buy a pressure cooker if you don't have one. So the prerequisite, and take note of that, the prerequisite of on-demand self-service is for the consumer to understand their own needs and also to know which product or products can accommodate such needs. Okay, so a consumer can unilaterally provision cloud computing capabilities, such as server time. I've shown you, you can actually choose that I want it for a day, for a week, for a month, or for a year, depending on how much you want to pay or for how much your needs are, how much you want to use it for. So you can also choose the network storage type, and also you can decide to have them to be elastic depending on your needs. And this is what we are calling on-demand self-service. So let us also look at another advantage, all characteristic, which we are calling broad network access. With broad network access, we're already seeing the word network. Can I ask, if I didn't have internet, would I be able to go onto my console And would I be able to provision myself a server and set it up in the cloud? I wouldn't be able to. But if I had internet and I have access to the network, whether I am in Uganda, whether I'm in Brazil or Africa or Europe or Asia, I am able to access my server and configure it and access the services as long as there is network access. And this is what we are calling broad network access. Cloud computing is computing power over the internet. I must emphasize that. So network access is an intimate characteristic of cloud computing. Today, the internet has reached almost every corner of the world. I repeat, almost corner of the world. So we can use any electronic device. I see some of you here connected using your phones, laptops, tablets, or even PCs. And this means that we can have access to cloud services through any electronic devices as long as there's network connectivity. Whether you're in office, whether you go back home on your personal computer, still you are able to use the services of cloud computing through the use of broad network access. Therefore, there's no way we can separate cloud computing from the internet, and kindly take note of that. And then another feature we are seeing here is what we are calling resource pooling. Just like you hear the word resource pooling, we are getting different resources from different hardware or from different hosts or CNAs, and we pull them into together to formulate one resource pool. Now, here what we are meaning is that for us to be able to have the ability to choose what we want, that I want a virtual machine with, let's say, 2 CPUs, with, let's say, 16 GB RAM. Before we even get there, we need to understand that resource pooling is one of the prerequisites. Before you get into on-demand self-service, we need to know that resource pooling is one actual of the prerequisite of on-demand self-service. Why? Because with resource pooling, we are going to decouple or put together different computers. Yes? Let's say this one has 6 CPUs. We put it together. Let's say also this one has 6 CPUs. And also this. We add them and we connect them together, and we have formulated our resource pool. Now, our end user who is going to come and they pick the different resources available, they are going out to choose whether they want one CPU, because we have already virtualized these environments to formulate one resource pool. And like we gave an example of a supermarket, we have different categories put into different areas, like the fruits, like the hardware, kitchenware, toiletries, and all these customers can quickly find the items they need, because they know if I go into this category, I can be able to get that. So resource pooling is just not merely putting all those resources together, but it is not just putting all resources of the same type together, but just putting resources together so that users can come and pick what they want. So resource pooling is also about breaking down the resources by finest grade or for flexibility and on-demand provisioning. That I want 1 GB RAM, I want 2 GB RAMs. So one thing you should note with resource pooling, just like you see an example of when you go to a drink out, or there's juice. Sometimes you just go and you get yourself juice from this tank of juice. Let's say this is the big tank of juice. You go and get yourself juice, but you don't know how many oranges they are put together, or how many teaspoons of sugar, how much sugar they have added into this for you to actually get that taste. But you will go and you will enjoy. You just get what you need, what is enough for you from this tank. Sometimes even when you go to the cocktail, sometimes it will even be hard for you to understand that they have put these, they have put this. So similarly, with resource pooling in cloud computing, we are saying that it is going to shield, and kindly take note, it is going to shield the differences in the underlying resources available. As I was provisioning my, let me just share the entire screen. As I was provisioning my server here in the cloud, as I was provisioning my databases, or let me even just use my Elastic Cloud server. As I'm provisioning it here, I am not concerned so much with what is the make of the computer. I am concerned with the speed of my computer. I am concerned with the different kinds of speed, storage. I am not concerned. Is it a Seagate hard drive? Is it a Western Digital hard drive? So that's what we are saying in our presentation here, that with resource pooling, it shields the underlying differences in the resources. So, for example, they also go ahead and use the analogy of serving drinks here, these drinks or carbonate soda drinks in the cafeterias. Usually, when people go and they get themselves, like, let's say, cola, they don't sometimes, when they're using these kinds of mugs, they don't know whether they're having Pepsi or cola because the dispenser has no brand on them, but they will just go, if it's a function, you get what you want from the dispenser, and then you're happy, you go and you only consume what you need to consume. So the keynote to take with resource pooling, one, with resource pooling, we are putting all the resources together to come up with one kind of powerful resource pool. But as we are putting them together, we are saying the end user does not even need to know or worry about the type or make of or the manufacturer of that given, or the difference in the different hardwares we have put together. That we have put together an HP server, a Dell server, and let's say a VMware server. They don't need to know that. As long as for them, they want to know, I want a computer with 6 CPUs, they'll be able to provision that to themselves, and they are good and they are happy to go. I see George, your hand is up.
Yes, please. I just have a question about the same resource pooling point. How does it become an advantage, yet it is, you said it's all about bringing resources together, but the customers, the consumers won't know what you brought together to make up a certain product. So how does that become an advantage? Thank you.
It is an advantage, one, because it is going to give you the ability to put different resources together. Yes? To put different resources together. You have your computers, you're going to put them together. You had disks, you're going to put them together, and you're going to provision them. Let's say you wanted like 30,000 terabytes. You won't be able to achieve that with a simple node, with a simple CNA or computer node or server. You need to have some kind of resource pool where you're going to put this one, which has 10,000, let's say 10,000, and you form your resource pool, okay, of your resources available. But then how it becomes an advantage, because it's going to shield the underlying differences. You very well know that in the traditional IT, some applications will not work because of compatibility with the differences in, let's say, the make of the hardware. But here you're having an opportunity. Let's say you're having a CPU made by Intel, you're having AMD on this computer, but the end product or software that is going to use that is not even concerned with the make. All it needs to know, I need this kind of computing power, CPU resource. I need 5 CPUs, each are running at, let's say, 5,000 megahertz or gigahertz per second. That's all the software is concerned with. So therefore, it has given us an opportunity of putting all resources together. And as we go and dive deep in cloud computing, you're going to appreciate the advantage of having the ability of putting different resources together so that you can have more computing resources at your disposal. I'd really love to take questions at the end, but let me take Judith, and then I proceed. Yes, Judith. Judith and Sally Paul, I see your hands are up.
Yes. Should I speak?
You can speak, Sally, because I can't hear Judith.
Okay. Now, I just wanted to compare about the resource pooling. Can I compare it as the one of internet, which pulls all the servers, the webs across the world into one internet? Is it?
Yes, that would be a good example to try and paint a picture of what you're trying to mean. But even better here, we are talking of putting together computing resources. Like as you said, pulling all the different web pages, like let's say the search engine, and you bring them at your disposal. But this time around, we are putting together resources, let's say memory, let's say CPUs, let's say storage. You get the point now, eh? So I'll take the questions during the break. Allow me to proceed, and then I'll take the questions later, because sometimes it can be a bit distracting. Just note down what you want to ask, then we shall come back to it during our 15 minutes break. Okay, so we are going to have a break at exactly 7. And during that break, I will also share with you the registration link. Kindly make sure you register. And as you're registering, make sure you put in your correct email, because I saw like about 6 emails that bounced. And then someone comes and they ask you that they didn't receive emails. But yet, in actual sense, they're the people who inputted those emails by themselves. So kindly just cross-check your details. See if they are the actual correct details before you submit. Okay, your name, your email, your university, and the program which you're doing. Okay. So, let me see what's in the chat. Okay. All right. So I'll come to those questions later on. So that is resource pooling for you. So computer resources that we are talking about, they include memory, and also they include CPU resources. So pooled CPU resources are available to consumer per core. Consumers have no idea, like I said, whether they are using AMD or they're using Intel CPUs, but in this case, they are actually using the resources that they need at that particular time. So let us also go ahead and look at the fourth advantage or characteristic of cloud computing. And with this, we are looking at it and we are saying that it is rapid elasticity. Before even I talk about it, let me just give you an illustration of this Monkey Kong. This monkey here you're seeing here, the Monkey King, is some game that is so common, very common in China. And what happens, it has a magic rod, this magic rod, which it uses to achieve given tasks at hand. So with this magic rod that it has, depending on the task, and let's say, for example, if it is fighting a monster, okay, if it is fighting a monster of that size, it will put out the magic rod, which matches the size of that given monster. And if it also needs to fight a bigger monster rapidly, this rod is elastic and it will expand and grow depending on the task at hand. If the monster is bigger, then also the rod will be bigger and more powerful. As it also advances and the monster also grows bigger, also the rod will grow to enable this Monkey King to be able to accomplish the task of finally fighting this monkey that is or that monster that it has to fight. So with rapid elasticity, like you hear the word elastic and rapid, we are saying when demand is there and it is a lot, to be able to rapidly and elastically provision computing resources, sometimes we are calling this or referring to it as rapid elasticity. So when the load surges, so what happens if the load is a lot? If let's say it's during the peak hours and all the customers are buying, like let's say on Christmas, what will happen in cloud computing using this characteristic or advantage, your server or your platform will rapidly expand or rapidly provision for you the kinds of resources you need at that given time. And when the load surges during the peak hours, or in the case of major social or commercial events, like let's say on Christmas, more servers can quickly be provisioned to you, and automatically in most cases or some cases, depending on how you're configuring it as you're provisioning or as you're setting up your cloud computing services. You can either set it to be automatic, or to get a notification. Usually you get a notification as an administrator that actually your resources are clocking over 75%. I think it's time for us to provision more resources to the server. And this can be done when the load reduces. The servers also can be quickly released, and you're not charged for those servers that you're not using. The beauty with this is that, remember, in our traditional, for you to better understand this, in our traditional IT infrastructure, you have your data center somewhere, your servers, on-site servers. So what happens during peak hours, let's say you set up your e-commerce company, and let's say during, let's say some kind of festive day, people are buying from you. So as people are buying from you and it is peak hours, you realize that actually your servers can no longer be able to support all the transactions that you're getting at that time. There's no way you can actually add more resources to, or actually hot migrate your software to another computing node which has better resources. You will have a bottleneck somewhere. You actually have to turn off your server. After turning it off, then you are able either to, if you have another slot available to you of memory, let's say if memory was a problem, you remove your 16 GB chip and put in your, let's say, 32 GB chip, and then you power it on services. And in this case, imagine there's a client somewhere trying to access the platform, and they're telling them internal server down, internal error 500, internal server error. You see, all these are issues with the traditional way of doing things. But with the rapid elasticity, what we are saying, depending on your configuration, during the peak hours, as people are making more, actually you just get a notification and automatically they add you another server, and even your client does not feel a pinch. They have smooth running processes, and they're able to transact on time. And also for you, you are busy making money and you're happy. And now it is now February, the festive season is done. You no longer need the server. You just they'll just release it and you don't pay for it anymore, and you just have this. Thereby, there's value for money. You are saving as an enterprise. At the same time, you're also not losing customer because of downtime. So that is one of the advantage of all the characteristic of cloud computing, which is rapid elasticity. So rapid elasticity, it has both scaling in or out, and it can be achieved manually based on the predefined policies. Scaling can be done by either increasing or decreasing the quantity of servers, or by increasing or decreasing resources available with each server. Like let's say that we add more CPUs or more memory on this server, and this can be done live without you necessarily having to first pad off your server and then you have it powered it on. So the most significant benefit of rapid elasticity is cost reduction with guaranteed business continuity and reliability. For example, with these characteristics, a startup company can start by acquiring only the amount of IT. You just go in the cloud, pay for one server, only the amount of IT resources that are needed. Let's say you have just started your startup, you don't have enough resources, you only have like about 10 customers which are making like 2 transactions per week. You don't have to first go and order very super expensive servers. You can start up with this, but as need arises, then the company can quickly obtain more resources just by clicks, more resources to handle more load surges and also release them after. So after, when you don't need them, like during Christmas, God helps you, you get more clients, you can actually acquire more servers, run your business during the festive season. After, when it is done, you can actually release them and you're happy, your clients are happy, you have made money at the end of the day. So this allows the company to spend its limited budget on higher priority aspects of their business. Let us also look at another, we were supposed to look at, yes, measured service. We're looking at measured service. You saw me, there was a way I was being able to determine that I either need 16 GB, I need 2 CPUs. By the fact that I'm putting quantity to it, there's a way of measuring things. And we are saying that measured service is how the cloud systems control a user or tenant's use of resources by leveraging a metering capability. Metering is not billing, and I want you to take note of that. Metering capability, and metering is not billing, although billing is based on metering. So like you see, I'm using my Amazon free tier services. I'm not paying for those services, but there's a metering capability of knowing that I'm actually going to set up, or I'm going to establish and use 2 CPUs or 1 CPU and maybe 2 GB memory. I'm already metering myself and determining even for how long I'm going to use it. I guess I'm going to use it for 1 month. That is already metering. And we are saying here that metering is actually not a billing. Although billing, they use metering to actually come up with your bill. So depending on what you select or what your meter is reading, that is when they actually come and bill you. For example, I'll give you an example of your water services. As you're using your water utilities at your home, okay? You have water they are paying and the meter is running. They're actually metering you. But it does not mean that whenever you clock, let's say 2,000 liters, that is a bill for you. No. But during billing time, when National Water and Sewage Corporation wants you to pay, and Sewage Corporation wants you to pay money, they will come and look at your metering and they will base on that metering to charge you. But it does not necessarily mean that metering is billing. I want you to get that difference. Sometimes you students get that question during the tests or assignments or the final exam, and they tell them that measured services means blah, 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 and it means to billing the customer as per use or as when or how long they want to use a service. True or false? And they select the answer based on what they know. So I want you to get that straight. That much as we are using metering service, the measured service or the metering service to bill, it does not mean that whenever they meter you, they're actually billing you. Okay? So I want you to understand that also. So in cloud computing, most services came with a price, while others are free. Like I've just told you, I'm using the free tier offered by Amazon. You can actually also go ahead and create your own account and you are able to use. Even Google provides the same. For example, auto scaling can be provisioned as a service, and most of the time this service is free by many of the different cloud computing service providers. So measured service ensures that all the resources users can be accurately measured through technical or other means based on the predefined criteria, which sometimes it can be duration of usage, the resource quota, or the volume of data transmitted. With these, cloud systems can automatically control and adjust resource configuration based on the usage. If the usage is high, then they can actually, based on that metering or measured service, to understand that it has now clocked 75%. Now we need to provision a new server for us to be able to work smoothly, or so that we don't have bottleneck. So let us go to the next slide, and with this slide we want to still go ahead and define what is cloud computing. I said before, and I'll say it again, that the IT industry must have at least 100 definitions of cloud computing. One of the most widely accepted is given by National Institute of Standards and Technology, the NIST of the USA. And here they're saying, or they're telling us, that by the National Institute of Standards and Technology, and it defines cloud computing as follows: that cloud computing is a model for enabling convenient, or that word, convenient and on-demand network access to a shared pool of configurable computing resources. And these resources sometimes can be network, servers, storage, applications, and services, and other services. And these can be rapidly provisioned, and we say that is rapid elasticity, and released within minimal management effort, all service provider interaction. And we say that is on-demand self-service. So some of the key points to note from this definition is that cloud computing is sometimes not a technology, but more or less a service delivery model. And cloud computing gives users convenient access to IT resources, including network servers, storage. You can actually get storage in the cloud. Applications, you have mentioned so many of them. Services like using utilities. Utilities, for example, you can understand the way you use water and electricity. So rapid resource provisioning and reclamation fall into the rapid elasticity characteristics of cloud computing, while the minimum management effort and service provider interaction falls under the on-demand self-service characteristics. So basically, the metaphor of cloud computing, refer to the internet, or cloud is a metaphor for the internet. It is an abstraction of the internet and infrastructure underpinning it. So while computing refers to the computing services provided by sufficiently powerful computer cable for providing a range of functionalities, resources, and storage. So you put together cloud computing, and it can also be understood as the delivery of on-demand. It can be understood as the delivery of on-demand measured computing services over the internet. And that is what we are calling cloud computing. So let me see the time. Okay. We are going to, let's go through the brief history of cloud computing, then we have a break. Then from after the break, we shall continue with the history of computing. Okay? All right. So let's look at the brief history of the internet. Many of you have heard, and many of you have heard stories that the internet started with the military, or some kind of network connection started with the military. And here we are looking at the year of 1969. And I repeat, you don't have to cram these things. We just need to, you don't have to cram the years or anything. I just need you to understand where we are coming from to where we are today or even beyond. Okay, so let us look at the brief history of cloud computing, or the origin of the internet. So in the beginning, all computers were separated from each other, that we know. And data computation and transmission were all done locally. Later, the internet was born, which was connecting all the computers and also the world together for us now to have what we're calling the global network of computers. So following some of the milestone events in the history of the modern internet. And I'm saying in 1969, ARPANET was born. ARPANET is the Advanced Research Project Agency Network, and it is widely recognized as the predecessor of the internet today. Like many technologies that are underpinning our modern society, ARPANET was originally developed to serve the military purposes. We all agree. It is said that the ARPANET was launched by the US military to keep a fault-tolerant communication network active in the US during or in case there's any kind of nuclear attack. So usually they had 4 nodes that used to connect the ARPANET. And these were the 4 universities that they used to connect the internet. But all these, they used to use different languages. So, but the birth of ARPANET marked the beginning of the intranet era, or kind of period. In the coming years, more and more nodes joined ARPANET, and usually for security reasons, they decided that 45 nodes should be removed from ARPANET, and then they should be put on a different military network, which they called the Mininet, and the remaining nodes were then used for civilian purposes. And that was a key milestone, because now the military was like, okay, I think for security reasons, since these people who are doing research, these universities doing research, I think let us take away our 45 nodes from ARPANET. We form our our network for security purposes, and then the remaining nodes, let us give these nodes to the civilians or for the society so that they can actually network and begin to grow. So we are seeing here, and I want you to take note of the birth of ARPANET, the things you should take note of, and also the complete specification of TCP IP protocol suite. It was established in 1981. So these were released for the first time, signaling the birth of internet communication language. We all know that TCP is a reference model, just like the OSI model, and it is a suite which has so many other protocols within it. And why was TCP needed? TCP is in fact a suite of many protocols. It includes the transport control protocol, you have heard of it, the internet protocol, or what most of you are calling the IP, the internet protocol, and so many other protocols. And these protocols, some of them were actually in the earliest ARPANET. But also the earliest ARPANET had network control protocols, which protocols were not some very compatible with other networks. And as they determined to grow, these networks these protocols could not support a network at a large scale. So the significance of coming up with this suite of TCP IP was significant because it is a standardization that would enable different applications or different computers to communicate with each other using standardized protocols or sorts. So ARPANET, Prenet, and StatNet communicated through TCP IP. So they decided to join these other nodes, and they were able to communicate through this different given protocol in 1983. So I want you to, for now, take note of the birth of ARPANET, TCP, IP protocol, okay? And then also DNS technology was introduced. Prior, if you're able to see if maybe before, if computers wanted to be able to communicate with each other, they would just use IP addresses. But now I am able to ping Google, and I am pinging it using a domain name, which is google.com. But prior, let's say if I wanted to ping google.com, this would be the IP address. I would go actually, and this would be the IP address. I would cram or get in my head. I go to my browser. For example, I go to my browser and I go to my browser here and I type in my IP address. Okay, so imagine whenever I had to go, of course, Google has different IP addresses, but imagine whenever I wanted to go to google.com, I have to cram and understand this IP address in my head. I need to cram 216.58.223.11 whenever I wanted to go to google.com. For me, I should cram that number. It was not feasible. And remember, now there are so many websites. You being able to remember this IP address is not feasible. Or even the link, let's say, if I wanted /1, and things would be written in IP addresses. So they decided that, you know what? I think the domain name system was important, and that's why in 1984, as we are seeing here, they decided to come up with a domain name system. Since the adoption of TCP/IP, the development of the internet picked up speed and more computers were added to the network. But remember, each computer had its IP address to identify each other. So remember, and cramming all these IP addresses in your head it is very hard to memorize. This is comparable to people's identity numbers. Imagine if for you to be able to call me by name, Sandy, you go to my national ID, you look for my name. And whenever you write a letter addressing me, you write that long number. It would be hard to memorize and remember and also to call out. So in this way, computer users can allocate their peers simply through domain name servers, leaving the translation work to the domain name server. So the domain name consists of two parts. Okay, it consists of two parts. The .com, for example, the commercial part, or .org, .organization, .tech. Nowadays, that other top level is becoming, there are actually more domain top levels that are coming up. But prior, there were a few of them, like just .com. And now, we also have the name part, okay? The name part and the category part, like let's say google.com, huawei.com, and so many other things.com. So today, domain names use URL. And these can be used to the universal resource locators, the name like www.google.com. And this can be used to identify any web page across the globe. You don't have to necessarily cram and remember the long IP address for that given resource that you're trying to locate on the internet. So take part of that. So in 1986, the modern mail routing system was developed. In 1989, the first commercial network operator, PSINet, was formed. So we continue and we go and we see that in 1990, the first network search engine, Archie, Google was not the first search engine. So Archie was the first search engine. It was launched in 1990. And also, most importantly, I want you to note these things. ARPANET was born the TCP protocol was established. From the TCP protocol, we are seeing the domain name server. These are some of the key milestones that I'm highlighting. And from that, we are seeing www was officially opened to the public in 1991. So www is the World Wide Web, or simply the web. And most of us now on a daily basis, I don't know how many times I've visited the web today. We are seeing here that the web allows hypermedia, which can be documents, voice, video, and a lot more, to be transmitted over the internet through the use of a web browser. It also, it was only after the popularization of the web that the great internet companies were born, and all kinds of applications that were fundamental or that have disrupted our world today. It's because they made it available to the public. That's when now people decided to become innovative, and that's why we are seeing in 1995 platforms like Amazon, or e-commerce platforms such as Amazon and eBay were created. Now, Amazon is very key when it comes to cloud computing. He was one of the key, very first players. And we cannot talk about cloud computing without mentioning Amazon. So also take note of that. And we're seeing that in 2000, the dot-com bubble burst. The dot-com bubble burst basically is the unprecedented growth of the internet in the 1990s, which resulted in the dot-com bubble, which bubble it happened, I think, around 2000. It was during this time that PSANet, the first commercial network, were mentioned earlier, went bankrupt because people didn't know what was going to happen next. So in the bubble, people thought a company is really going to actually be able to make money, what is going to happen. So until when the internet regained its growth after, in 2004, when Facebook was first founded, and it came up with a phenomenon of social networking. And then also the browser alliance led by Google reinforced the support of HTTP hypertext transfer protocol using a secure layer, was also enforced or reinforced in 2014. So in summary, what I want you to note, don't even try to cram the years or anything, just note these key milestones, that ARPANET gave some kind of birth that actually computers could be connected together so that people could share some kind of resources or information. But now they had to come up with standardized kind of protocols to enable them communicate with a rapid growing, and also to regulate how computers are going to communicate and send data over the network. So the TCP/IP protocol was established. And then also we are seeing that in 1984, the domain name system technology was introduced to help us convert from the IP addresses to a name that is closely or easily remembered by human beings. And then also we are seeing that in 1991, the World Wide Web was officially opened to the public. Okay, so that is it for now. After the break, after we come back from the break, we are going to take a break of 20 minutes, and we should be back on the call by 7:20. Or some of you could choose to stay, but I advise that you stay because I'm going to be sharing the link to the attendance in the chat. So kindly click on that and you're able to register. So we are going to resume at 7:20, and at 7:20 we are going to continue with the brief history of computing. We have looked at a brief history of the internet. Now we are looking at the brief history of computing. And we said, like, for us to come up with cloud computing, we need both the cloud and computing, or the internet and computing. Okay, so for those who have questions, I'm going to take a few questions. After up to like 7, in the next 5 minutes, I'm going to take a few questions up to 7. Then I share the link for registration for today, and then we shall resume at 7:20. Yes, I see Judith. I see your hand is up. It has been up for a while. Talk to me. Yes, Judith. Your hand is up. Or I see Benya.
Hello, Sam.
Yes, please.
Yeah, unfortunately, you let us compile a lot of questions, so it could take longer than you anticipate.
Okay.
Yeah, so my first question is, you gave us the definitions and everything about cloud computing, but the question is, what can trigger your decision to go cloud, to do cloud computing? Because I don't think it's suitable for everyone. Okay, in my opinion. Not anyone can go to it. Now imagine a company very young, and then they don't have the financial muscle, because a company might be able to buy an on-premise server, but they can't do the monthly recurrent fees for cloud computing, yet they have to work. So what really triggers your decision? Should everyone just go cloud, or should there be people who should remain in their premises doing their work at their own pace? And then another question is about what is your take on the fact that cloud computing will take people's jobs, and those people's jobs which are going, for instance, data center attendants or engineers, trust me, they'll lose their jobs. What will they do next? Because if most of the companies are doing cloud computing, then it is the service provider who will require this kind of human resource. The rest who will be subscribing will not need this human resource, because you won't need these people anyway. So what's the next step for those people? Another question still is about the billing. You were talking about billing, and you gave an analogy of National Water and Sewerage Corporation. Is it the only way they can bill? Is it supposed to be prepaid or postpaid? Can I use the service to a certain level and then they bill me later? Can it keep on scaling up to as per my demands, as per my company's demands, and then later they just give me a bill at the end of the month that this is what you used? And what if I fail to pay? What happens? What are the legal implications? That's all for me for now.
Okay, thank you, Benya. I see Wandera.
Okay, thank you, sir. I had just one question. You talked about the advantages of cloud computing, and you talked about resource pooling. I just wanted to know, to seek clarification, is these advantages on the side of the client, the one getting the service, or is it an advantage to those IT firms providing these services? Thank you.
Okay, thank you, Wandera. I'll take Patrick.
Yes, thank you, Samuel. I'm Patrick from Muni. I want to relate to the issue of resource pooling and associate internet or computer use with power. Because if there's no power, I don't think anyone can use their computer. Assuming there's a major breakdown in the power system where you have your cloud resources for use, how can that affect your use of the cloud computing?
Okay, thank you, Patrick. I'll take George, then I come to you, Joanne. George? Okay, Joanne, you can speak to me. I think George
I just wanted to answer the person who asked whether cloud is a necessity.
Okay, you can go ahead.
The world is moving. I think you go to cloud when you feel you need it. For example, if you want to save your contacts via the Google Drive and it's a necessity, so you go to cloud. And I feel like the way the world is moving, it's cloud that is taking us. So cloud is a necessity.
All right, thank you, Joanne, for that submission. We'll take George, and then George and Robert. That will be. I'll take Robert and Eliane. Eliane and Robert. One of you can come first.
Hello, everyone there.
Hello.
So, I would like to clarify to whoever has not understood the cloud computing. They will have to know that whichever website exists, it exists on a cloud. That's a simple way I can try to explain to them the cloud computing.
Okay, thank you so much.
This is Robert.
Yes, Robert.
Yeah, mine. I was trying to respond to the person who said, does this resource pooling benefit the client and the owners of the owners of the servers and so on and so forth? I would say that I think it does. It benefits all the people involved into, because the way you explained it was in the way that if a client is on the other side suffering, basically
you can continue.
Basically, you will need more of the resources so that your client does not face difficulties in accessing your product. So basically, it will solve all of you as a client and as a server, maybe the owner of the server, the other side. Thank you.
For me, like when.
All right. Yes, Precious. I saw your hand was up. You want to talk to us?
Yes, talk. Yeah, you do.
Yeah. Hello. Hi.
Hi, Precious.
How are you doing?
I'm okay.
Thank you very much for the service, first of all.
You're welcome.
Yeah. It's a bit off of cloud computing. Sorry for that, but I'm wondering if you had anything to do with routing and switching, security, and things like that, and wireless as well. Will those be offered? I noticed in your group, I think some of them have already been done. And I think I missed out on that, or a lot of us missed out on that. I don't know, but I'm just wondering if maybe in the future.
Yes. Those opportunities always keep coming, and as they do, I usually share with the groups of the people who have been attending them. And my next class will be in security, HCIA security. So after this class, I'll also be able to share the links for those that are interested. So let me try and respond to some of these few questions because I see we are taking some of the minutes for your break. So Benya was asking and saying that most of the colleagues have answered you and saying that it's usually when it comes to your needs, what do you need as an enterprise? As when you compare cloud and let's say to the on-premise data centers, what works best for you as an enterprise? Okay, so this sometimes means, for example, you gave an example of a startup company. If you're a startup company, let's say, how much do you have? How much data do you need to store actually on your servers if you're a startup company? But you very much know that you can actually start up a server on Amazon as low as $20 per quarter of the year, depending on what you want to transact on that. But you'll find yourself that you're going to spend let's say 5 million Ugandan shillings to acquire a server that is going to be able to run what you actually want to achieve. And let's say you have just activities, maybe let's say they're daily, or maybe they're monthly, or they happen once in a while. So if you're a startup company and you weigh and you see, can you really afford to hire a system administrator? Can you afford to hire an operations and maintenance administrator? Can you afford to hire a network administrator? Because that means if you have a server on premises, you need it to be networked to the internet, provision it with a static IP. You also need to buy a firewall. So ideally, all the operations and maintenance are shouldered onto that startup company. So you have your system admin, your database admin, your software administrator, your network administrator, and a startup company. Do you have the resources to pay those people monthly? And can you realize that actually the money you pay one guy, you could actually decide to have most of, to actually go to the cloud and have yourself a server. You just need to hire now a cloud computing engineer who is actually going to help you roll out those services, as opposed now to having to pay all those people to be able to run the different services on premises. But still, even when it comes to cloud computing, and we're going to look at it in the next chapter, we have different kinds of cloud computing. We have private, we have public, and we have hybrid. An enterprise may choose that, for this kind of data, we feel it is so sensitive and we want it to be on our site in premises. And now for this, and since it's a lot and huge, and we need maybe very powerful servers, which will be very costly to buy and maintain, because also the cold room or the server room has to be maintained. You need to provide internet to it, you need to provide power to it, and you need to keep it cool all the time. So you actually, ideally, still spending on it even more. It's not just about buying the server, but still there are those other expenses that you have to incur as a startup company. So as you sit down and you do your SWOT analysis and you try to weigh, if I decide to take this direction, what are the advantages that I will benefit, or what cutting edge do I have by having on-site data centers, or how do I benefit by choosing to migrate to the cloud? Because what happens is, like my colleague says, what will happen if there is a power outage? These cloud computing providers give you an opportunity of an uptime guarantee. They actually guarantee you that your server will be up 99.9% all the time, which is actually difficult to maintain if you're having on-site premises. Umeme will go, they will be working on your connection, working on the road, they cut your fiber coming to your enterprise or location, and then you end up finding or failing to people failing to connect to your data center simply because it's on premise, and there are all those other disadvantages that are attached to it. But if you are a company and you feel like I'm not secure having my data in the cloud, I want it to be on premises, then there you choose to have your data center on the premises. So like the way Elian said, or Joan, it entirely depends on your needs as an enterprise. You sit down and weigh, and this course now, like our friend said, I want to try and also throw my light. Who asked about the advantages? As you're taking this course now, first stop thinking of the advantages as the end user. Now start thinking of the advantages as a cloud computing engineer, because now we are actually training cloud computing engineers. What would be the advantage for you? What would be the advantage for you, Wandera, to have the ability of putting different resources together and having one applications run on that, having applications run on those resources? In the traditional IT, you cannot run, let's say you cannot install Windows operating system and Linux and you have them run at the same time using the same resources. either you have to first switch off, shut down Windows, and then you boot into Linux, or boot into Linux and shut down Linux and boot into Windows, but you cannot them have run concurrently. But you see, with the power of cloud computing, which builds on virtualization, you can actually have different virtual machines of Linux and Windows and whatever, name it, all running and sharing the same resources. And you're going to appreciate that when we come to virtualization. So we are saying resource pooling, it gives you the ability of putting all the different resources together, memory together, into like a resource pool, where someone will just come, where you create a virtual machine and you allocate it your desired resources, like let's say 2 GB and 4 CPUs and name it, and so on and so forth. So still, Benya talked about data centers and taking jobs. Yes, like any industry, as long as you don't equip yourself with the emerging technologies. Sometime back, typewriters, the people who used to know how to use typewriters were the cutting edge. You get a job and you sustain it because you know how to use typewriters. The document processors, people who used to write letters for people, nowadays they are irrelevant because people process documents for themselves because they have document processors on their phones, on their computers. But if, and only if, those typewriters then decided to acquire the new skills and actually evolve them into a better paying job, that is when now they can be able actually to benefit and leverage on the current trend or what is happening today. So yes, if you decide not to equip yourself with the new technologies, I know so many system administrators who are now either certified Huawei cloud computers or AWS or GCPs. Yes, so it is entirely up to you as an individual. If you know you're in a field and you know there's this new thing, and if you don't equip yourselves with that knowledge and skills, you'll definitely be left behind. IT is a very changing industry, and you need to change with it as it changes. The beauty with a skill, once you get a skill, it stays with you. It's only a matter of time for you to improve it and grow with it as you gain more experience. Okay? So you also talked about billing national water. It depends on the arrangement that you have with your service provider. But some of them it actually entirely depends. Some of them you pay before use. Others, you pay for how long and how much you're going to use. Others you use, then you pay, depending on the kind of arrangement that you have signed up for on that platform. Yes, so okay. So we are looking at the brief history of computing. We want to understand briefly, and we are seeing that traditionally, or how computers used to, before we even think of coming to cloud computing, before we even think of coming to cloud computing, we are saying, or we are seeing that traditionally computers used to process software in a serial arrangement, okay? What we are calling serial computing. So what happened here is that each instruction or a problem would be broken down into discrete series of instructions. These ones that you're seeing. So we have one problem here, and with serial computing, we break our problem into series here, discrete series. We break them, and then these series are now executed one after another on a single CPU. That was serial computing. That was, and that is, take note of that. That was serial computing. So, and we are saying that only one instructions may be executed at any one time. So it comes one by one. This one is executed, it goes. This one is executed and it goes. So we are saying with serial computing, a complex problem takes a long time to process. With a large-scale application, especially when there is limited compute resources. Sorry about that. I think I had a network glitch. Can you hear me?
Yes.
All right.
Yes, we can hear you.
Yes, yes, yes.
What did you last
Yes,
hear?
you can.
What did you last hear?
Can you hear me?
That's what you last said.
But can we hear you?
Okay, I'm meaning referring to what I was explaining.
No, we had you laugh.
Yeah, actually, explaining completely.
It was what?
About serial computing.
You were explaining the problem in
Serial computing.
Okay. All right. All right.
Period.
All right. All right. Some of you are attentive. Okay. And
yes.
so I was saying, when it comes to powerful computing, serial computing here could not enable us or support us to perform complex processing, which required us to have problems or instructions being processed simultaneously, all being executed at the same time. Okay, so that is one of the challenge of serial computing. So limits to serial computing, both in theory and for practical reasons, they pose significant constraints to simply building ever fast serial computers. So we have transmission speeds. The speeds of serial computer directly depend on how fast the data can move from hardware. That means the input and output, and absolute limits are the speeds of light, 30 centimeters and nanoseconds. So there's a limit to miniaturization, which are processor technologies allowing an increasing number of transistors to be placed on a chip. There are some, when you have a CPU, it has different transistors placed on it, but you cannot place millions and thousands and billions and trillions of them here. There's a limitation to the amount which can be supported on a single CPU. So those are some of the limitations. And of course, for economical reasons, it was very expensive to make one single CPU processor very powerful, meaning to make it smaller and attach so many other capacitors and resistors on it so that it is able to solve the problem of being, or actually to try and execute these problems faster so that we get this problem or job out of the way. So in the simplest sense, prior computing.
Book of Revelation, chapter 7, verses 16 and 7.
Okay, someone is playing Revelation chapter 6. Okay, thank you for muting. Thank you for muting. So I was saying, in that sense, or in that way, that's when they decided to come up with parallel computing. Like you hear the word parallel. This job is broken down into these parts that you're seeing: part 1, part 2, part 3, and part 4. Yes, and we are seeing that parallel computing is the simultaneous use of multiple compute resources to solve a computational process. Here we had just one CPU. In parallel computing, you're seeing you're going to use one CPU, two CPU to come and solve this one problem which we had. What we are going to do, we are going to just divide it into different parts, and these different parts are now simultaneously being executed by one of the CPUs. So this means that it is faster. It will get the job done faster, as opposed to just serial computing, which breaks the problem into just discrete series, and then it starts executing it one by one. Okay, so here we are seeing that each problem is broken down into discrete parts, these parts that you're seeing, that can be solved concurrently, and each part is further broken down into this series that we're seeing. So we are seeing how serial computing is somehow embedding itself in parallel computing, or we are seeing how parallel computing is building on serial computing. So instructions from each part execute simultaneously on different CPUs, CPU 1, CPU 2, CPU 3. Okay, and a unified control mechanism is added to control the entire process, and after the user gets the result from the entire process. So traditionally, parallel computing has been considered to be the high end of computing and has been used for cases such as efficient computing and numerical simultaneous of complex systems. So today, commercial applications are providing an equal greater driving force in the development of faster computers, and these applications require the processing that is similar to this parallel processing. So the reasons why parallel computing, or why we would prefer parallel computing, is that because it saves both time and the costs. In theory, using more compute resources will lead to completing attacks faster and save potential costs. This is even more true considering the resources can be inexpensive and even out of date CPUs cluster together. Okay, so and also solving larger problems that can't be handled using serial computing. So if a problem is bigger, with parallel computing, you actually break it down into these discrete parts, and then after simultaneously solve or fix them one by one. So let us also look at grid computing. So we are seeing with grid computing here, we are going to use widely distributed resources, computer resources. We have, maybe this is a storage server, we have a laptop, we have a computer somewhere, but ideally just think of these as different widely distributed computer resources, and we are going to get these distributed computer resources to reach some kind of common goal, that we want to have one kind of resource pool which is going to be powerful enough to execute the jobs that we have, or the job which we have at hand. So after putting all those resources together, this is some kind of special way of distributed computing. Okay, so we are saying, according to IBM, a grid aggregates compute resources dispersed across the local network or even the internet, making the end users or clients believe that they have access to one super virtual computer. Yet in actual sense, we are getting our storage, another computer, the resources, we bring them together, we form one kind of super virtual. Are you seeing this virtual computer here? And then the job is executed, or making the end user believe that they are actually they are connected to one big supercomputer, yet at the back there is a network of computer resources to that grid. Okay, and then we are looking at also distributed computing. With distributed, just like you hear the word distributed, we have it is a field of computer science that studies distributed systems. A distributed system distributes its different components to different networked computers which communicate and coordinate their actions using a unified messaging mechanism. The components work together in order to achieve a common goals. Now we have these different resources. So we have our job here, which is also divided into a subjob, and these subjobs are sent to these different resources, which use a unified communication mechanism or messaging mechanism to, at the end of the day, execute this job. So basically, we have distributed or different distributed components on different networked computers, which will handle this job by getting these sub-jobs to those different distributed resources, which sometimes people think and feel it is somehow like grid computing, because also grid, the difference with grid, it is widely distributed. Widely distributed, and for it, it is making the end users believe that they are connected to some kind of strong, powerful computer, and then which is going to execute the job at hand. And now we are seeing these three computing or history of computing. We are seeing that we also have cloud computing, and we have our jobs which are being executed in the cloud. And as you can see, cloud computing is building on the underlying structures of these things and did not take them away. When you find a question telling you that cloud computing replaced ABCD, no, it did not replace, but rather building on the ability of having computers which are widely spread but connected to them, abilities of having distributed resources on the network, and you have them to execute the job, or the ability of executing different parts of the problem simultaneously, but as you see, parallel is also using the serial way of executing tasks at hand. So that is the history of computing. And now let's try and look at cloud computing evolution. How has it evolved? Where is it now? And like we said, or like I said earlier, this course focuses on cloud computing 1.0. And with cloud computing 1.0, we are going to be focusing so much on virtualization and trying to understand how we can virtualize the different computing resources to be able to support the cloud computing. So this era of cloud computing 1.0 focused also so much on compute virtualization, and we are seeing some of the key stakeholders here. We are seeing Hyper-V. Hyper-V is offered by Microsoft. We are seeing Zen, KVM, VMware, EXI. These are some of the players when it comes to cloud computing 1.0. This phase deals with virtualization of IT infrastructure resources with focus on compute virtualization. Like I said, IT enterprise applications are completely decoupled when we are using virtualization. They are completely decoupled from its infrastructure. With virtualization and cluster scheduling software, multiple IT applications instances and runtimes can run and share the same infrastructure, leading to high resource utilization and efficiency. So virtualization, we are looking at utilization and efficiency. Not improving the performance, but we are now going to utilize the hardware resources so that we can give them work to do. If we have idle resources, we can actually provision them and they actually do work, and also for efficiency. So HCIA Cloud Computing, this particular course, mainly covers the implementations and advantages of cloud computing in this era 1.0. So we are seeing there's virtualization and high resource utilization in this era. And now cloud computing 2.0, we are seeing that infrastructure are provisioned to cloud tenants and users as standardized and automation of service resources here. They are made possible with the introduction of standards and, of course, service provisioning and resource scheduling automation software on the management plane and so on. So we have some of the key players: OpenStack, AWS, VMware. And when we see, but you see also to note that it is basically cloud-based infrastructure. And now another era of cloud computing 3.0 is cloud native app redesign. Basically, they are focusing on redesigning cloud native applications where we're seeing agile app development and lifecycle management. The key players, we have Docker, Core OS, and Cloud Foundry. You shouldn't these are just out of the scope of what we're going to cover, though in cloud computing trends, we shall look at some of them. So don't scratch your heads right now. We shall be covering most of them or many of them in the coming chapters. So now let us look at the cloud computing models. We have different models, and cloud computing has different models. So this section majorly talks about the differences between, if you want to, you can actually go and read further on these previous slides and read further on the differences just for better understanding, but not so much relevant towards you attaining the professional course, but maybe for you to understand and grasp the differences in the era or the how cloud computing evolved from cloud computing 1.0 to 3.0. Okay, so let us also look at the cloud computing models. Although not universally agreed upon, cloud computing is commonly categorized based on cloud deployment and service models. So we can categorize it by the way it is deployed or by the services you're going to use in the cloud. So first, let us focus so much on the deployment model, or categorizing it by deployment model. And we are seeing here that we can deploy it by either choosing to go by public cloud, by private cloud, or by hybrid cloud. And when you hear the word public, I want to ask now and have some kind of interaction. What comes to your mind? Someone can just say mic check and you say what you think.
Hello.
Yes, please.
Mic check.
Yes, go ahead and say, Pius.
Mic check.
Pius, you're breaking.
Something that is open to everyone. Something that is open to everyone.
Something that is open to everyone.
Everyone.
Okay, before you go, can you also tell us, when you hear private, what comes to your mind?
Something that is not that is meant to be accessed by only you.
By only you. Okay. Thank you, Pius.
Yes.
Can I get now someone to tell me, they are seeing this diagram and we are seeing some arrow dividing and we are seeing a word hybrid. What comes to your mind when you see this diagram and illustration and also the word hybrid? Can I hear someone else? Pius, thank you so much. Yes, Daniel, I see your hand is up. Yes,
Hello.
Joan, you're saying something.
Mic check.
Joan was saying something. Can we hear from her? Then I'm going to come to you, George.
According to the diagram, hybrid means a combination of public and private cloud.
Okay. Yes, George. George, you had something you wanted to say? Oh, sorry, Johnny. John or Tony something.
I think it's the same answer. What John said is like the combination of private and cloud, then it's a hybrid.
Okay, all right then. I see all your hands are up. You can just put your answers in the chat so we can move so that your colleagues are able to read and share with you what you have in mind. You can just go ahead and post. I see Peter is saying it is a public, but you have access to what you want, and what you can access is private. Cloud deployment model, the same as types of cloud computing. Partially paid for. Yes, you could say it's more or less the type, but we are saying these are, think of them like categories, how we can classify them. How can we classify cloud computing? Okay, how can we categorize it and you know that this is this type of cloud and this is this type of cloud computing? So you can still agree with me on that. So we are saying that with the public cloud, cloud computing, like let's say the examples we have been looking at, the Google Translate, We have been looking at Office 365. We have been looking at AWS, Google OneDrive for Microsoft, and so many other examples. So public cloud, this guy here, he offers utility-like IT services over the internet for the public. So here, anyone, as long as you want the services, and if you can afford them, some of them are even free, anyone can come and access and use those resources, just like the way our colleagues have explained, Pius and Joan, like the way they have explained. So you can come and access it. So public clouds are usually built, and take note, they are usually built and run by cloud service providers. By cloud service providers, and end users access cloud resources or services on a subscription basis. Okay, so you just subscribe and use what you want. Like if you want to use Google Drive, you sign up and subscribe to their platform, and boom, you start storing things on their cloud or services. But while the service provider takes care of all the operations and maintenance and administration responsibilities, you as the user of, let's say, Google Contacts, you don't even need to concern yourself and ask, did Google pay for electricity next month where I'm storing my contacts? Is the server in good condition? Do we need recabling? Do we need retrunking? Do we need to refill? Do we have backup, power backup? When are we going to maintain those servers storing those contacts? So all the operations and maintenance and administration, they are being catered for by the service provider. For you, all that you're concerned, or what concerns you is just subscribing and use a service, and they are available for everyone or to the public. And just like Steel Pius said, the private, it belongs to you as an enterprise. So private clouds are usually deployed for internal use, internally within enterprises, all other types of organizations. And all the data of private cloud is stored in the enterprise or organization's own data center. So all your data, it is stored on your premise, on your data center. Yes, somewhere, let's say somewhere, like let's say in Banda or Nakawa or Chukoni, somewhere, you have your enterprise, you have your server, server room connected, and you everything is private to you. And we are saying that here, the data centers or firewalls or control, the firewalls are what will control what enters and what leaves your network architecture, depending on how you laid out your architecture. So allowing most. So here, what the private does, a private cloud can be built based on the enterprise's legacy architecture, allowing most of the customer's hardware equipment to be reused. A private cloud may be able to deliver a high level of data security and allow reuse of legacy equipment. However, these equipments will eventually need to upgrade. If you had your RAM here, let's say you bought it in 2005, by that time, like in 2000, the 1 GB chip was hot, you had it then, but now it's no longer enough and need to upgrade. You find out that this server does not allow more than 4 GB. It only has 3 slots. And now you think of either throwing away this one and order from Dell or order from VMware to get you the EXI, and you install it on your premises. So with the time, you may need to do that. And you should also take note that all the operations and maintenance, they are on the enterprise. You have to say, Victor, we are okay? Okay, we assume that was a mistake. So all the operations and maintenance, the enterprise has to meet those high costs. Yep. So these hardwares, like I was saying, they will eventually need to be updated and upgraded to keep on with the growing demands of the organization. And sometimes this can be costly. And if you want to have strict data access control, and let's say like less data sharing even within the organization, this is some of the things that you encounter when you're dealing with the private cloud. So in recent year, there's a different type of private cloud that has emerged on enterprises to deploy a core applications in the public, and the core applications in the public, like let's say the dedicated cloud, they create for you a dedicated, it's like how you do have your own, you're not sharing the server with anyone, it's your dedicated server in the cloud to you on the public cloud. And this model offers dedicated compute resources and soft storage resources and reliable network isolation, like you can use a VNC and VPN, and hence there you are able to meet the high reliability, performance, and security standards for tenants' mission critical applications. And also let us look at, Elian told us and Joan told us that here we are seeing actually that this is a combination of both our public and also our private cloud. And when you look at it, we are saying that the hybrid cloud is a flexible cloud deployment model. It may comprise of 2 or more different types of clouds. Sometimes it could be private, and community. Usually community, just let's say healthy community cloud, or let's say like the way you see airports, like we shall be looking at it, but usually the community, you have a different community accessing or setting up one kind of cloud to be able to share and collaborate and share information in real time. So, but to sum up everything, the hybrid cloud allows users to enjoy the benefits of both the public and the private clouds. It also offers a great profitability for applications in a mid-cloud environment. In addition, the hybrid cloud model is cost-effective because enterprises have on-demand access to cloud resources on a pay-per-use basis. Okay, though sometimes the downside with hybrid is that you have usually require more complex setup, because you need to set up a cloud that supports both private and also public, and also the operations and maintenance. Sometimes usually they are complex. So a major challenge facing hybrid cloud is integration between different cloud platforms, different types of data and applications. So sometimes compatibility issues between different infrastructure platforms can be an issue. So like I said, there could be also community, or what we are calling industry. Okay, community, or what we are calling industry cloud. And here is where the cloud infrastructure is built and managed by a leading organization of a specific community and shared between several organizations, like let's say the medical practitioners, healthcare industry. They could decide to have their kind of industry or community cloud. So let us also look at the category of buy. This is the cloud that we're talking about. The banking sector could actually also choose to have its own, the healthcare, and also like let's say, I think this is the transport sector. Okay, so let us look at deployment. Okay, yes, these are more of the industry or the community clouds, healthcare cloud, financial, and there could be more depending on the nature and how the cloud is set up. Okay, so now let us look at deployment by service models. Oh, okay, by service model. Right, let me just check the chart just to make sure I don't miss out. Okay. All right, so so seeing here cloud service models, by service models, and we are looking at things on the platform. So in our traditional IT environment, we see that we have our server set up, or we have our architecture here, and this is what happens in our traditional IT environment. Usually, you will have our infrastructure, which infrastructure is going to contain the network resources. You have your network well laid out. You have segmented it very well, subnetted it very well. And we have the storage resources. You know, we are going to be keeping your data. And also you have the compute resources, memory, storage, input, output, and also you have your virtualization in a typical IT infrastructure, traditional way, okay? So usually we have that. And then the software bit, you will have to install an operating system on your infrastructure. You install the middleware that is required, let's say the drivers, libraries, and etc. Install the runtime environment, depending on the operating system you're using, like the .NETwork frameworks, and so on. Then also have the data that you're going to work with and the different applications. That is a traditional way, the things that we are used at. Even your computer, when you look at it, it has almost, or if not, the similar kind of architecture that we have. So now let us look at the different service models that the cloud is offering. And we are seeing here, we have already seen that in the traditional way, everything from the network resources to the application, everything is in-house. You have to acquire the network resources, storage resources, compute resources, virtualization operating systems, middleware, runtime, data, and applications, isn't it? In-house. Maybe you go ahead and buy an IP address from internet service provider, buy storage resources, procure compute resources, install virtualization tools and virtualize these resources. After install, buy the operating system and install it there, like Windows, you buy and purchase a license. If it is Linux, it is open source. You go ahead and install the middleware that is required. You go ahead, install the runtime, everything in-house. Get the data that you want your users to use or that supports the applications to run, and also go ahead and install those applications. That is a traditional way, how things are done traditionally without actually using the cloud services. Now let's look at what infrastructure as a service. This is infrastructure as a service. Okay, infrastructure. This is infrastructure as a service. When it comes to infrastructure as a service, it refers to a situation where we are going to have the infrastructure here, these things you saw when I was illustrating, being offered to you by the cloud service provider. Okay? And now in-house, you just go ahead, go on Amazon or like go on Huawei, procure a server. And after you getting a server, you have now to install your operating system, middleware, install runtime, the data that is going to support your applications. But basically, they just give you the infrastructure and you do with whatever you want to do on that infrastructure. So think about it like they just give you a computer which does not have any software online, or a server which doesn't have any software in the cloud, in the internet. So that is infrastructure, just like the way its name suggests. And now we are also seeing another service model, and it is called platform as a service. With platform as a service, we are seeing that the cloud service provider is giving us the infrastructure plus the software bit, plus ideally what we would call the platform. Yes, so we have the infrastructure, we also have the platform. Like let's say it's an Microsoft Windows platform, it's a Linux platform, it's a Ubuntu platform. So they also give you the platform with the operating system, with the middleware installed, runtime environment. And for you, what you need to do as let's say a cloud engineer, you just need to get the data that you need to support your application, put it there, and you're good to go. They give you platform as a service. Usually this is given to developers. Developers usually love using this kind of service model because they don't want to use a lot of time in installing and configuring runtime environment and testing out things. All they do, go to the cloud, get the runtime environment up and good to go ready. They just put their data, test out, make a few things, make changes, and they're good to go. And this is what we're calling platform as a service. And now also let's look at another service model which you're calling software as a service. This means for software as a service. Software as a service, the cloud, please Kamukama, do not automate on the screen. Kindly don't automate on the screen. So this is software as a service, and we are seeing that the service provider, the cloud service provider, is giving you everything. You don't have to write any kind of instructions or install any kind of instructions as to refer as to that software is concerned. All you need to do, get a software as long as you have it ready or you have a platform ready for you to use it, you're good to go and you're able to use it. Okay? So that is what we're calling software as a service. So they give you software or applications in the cloud ready to use. For example, like Google Translate. It is in the cloud. It is not installed on your machine. Much as you may need a browser to access it, or you could even access the app, but the app is just a platform for you to be able to access it. So you can access it anywhere. Okay? I look at Office 365. Live, please do not automate. I'm going to put you in the waiting room, and that could have consequences for you. Eh? This is a professional course I emphasize, so let us try and act a bit professional. All right, thank you. So, like let's think of Google Docs. Okay, you didn't install any kind of Google Docs, but you can access it and you write your document, you process your documents, and you're good to go. So that is what you're calling software as a service. Okay, so before I go to the quiz, could I get just a volunteer to just take us through the different categories that we have for just a brief recap that I've hinted on this and hinted on this and hinted on this to where we are now. Just a brief recap of the deployment. Actually, let me get one for the categorizing by deployment model, and I'll get a second one to categorize by service model. Let me see my participants here. Should I pick at random?
No.
I shouldn't. Okay, George, tell us. Give us by deployment model. George, your microphone has died now. Could I get a volunteer?
There's not dead, but I can't give a great explanation right now.
You can just hint on what.
I need some time to understand these things.
I see Patrick, his hand is up. Yes, Patrick. And then Joan will take us through by service model. Patrick, you can tell us by deployment model. Just you hint on, you talked of this, which means this, and this thing means that. Thank you.
Yes.
Yes, thank you so much.
Can I have Patrick? Patrick, yes, you can go ahead and speak.
Yes, I'm speaking.
Yes.
By deployment model, we have the three categories: the public cloud, the private cloud. Public cloud is accessible to everybody upon subscription. And then private is where which is an enterprise or by an organization and it's only limited to them. And then there is the hybrid, which combines all, including community deployment, which can be according to industry, say health, banking, and transport, and so on. Thank you.
All right, thank you. Thank you so much, Patrick. Douglas, I see your hand is up. Yes, Douglas. Douglas, okay, Douglas, we can't hear you. Sorry about that. Can I take, okay, Shamiru Kwesiga?
Thank you. Should I talk about the cloud service models?
Yes, by service model, yes, please.
Okay, what we have gone through, for instance, when I start from the traditional side, I look at it like an in-house data center, which is down floor, and service engineer is up, managing it as a whole infrastructure. Then when we look at infrastructure as a service, we are looking at buying a computer in the cloud. Like for instance, when you go to the Amazon Web Services and maybe get a virtual server, which is going to be this and that specifications for the purpose you want to use it for, whereby now after getting that computing part, you're able to install whatever you want to install, maybe a finance management system, and you're good to go. Then with platform as a service, we are looking at it whereby the service provider is going to give you both the infrastructure and some bit of the runtime environment. For instance, if I'm someone who's into websites, I'll get a platform which already has WordPress and the server and everything. All I have to do is to build the website on it. Then when we look at software as a service, it's where the cloud service provider is going to give you everything. For instance, when we look at Office 365, it's almost the same as having the Office Professional and so on. But for it, you have the server, the software, and everything already in the cloud. All you have to do is to open the application without installing it on your computer. Thank you.
All right. Since I see, thank you so much. That was detailed. Thank you, Kwesiga, for that submission. Joanne, I've seen your hand up. Do you want to say something?
He has said it all. Like I wanted to also explain the cloud service models, but he has explained them.
All right, all right.
Maybe I should give like something I understand, yeah?
Okay, that's okay.
So for traditional, in everything is in-house, like you have everything. The company has everything. It has the machine, the operating systems, everything is in-house. Then under infrastructure as a service, the cloud service provider gives you the machine. Then you have to install the operating system yourself and the data, what that is for the company. Then under platform as a service, the cloud service provider gives you the machine having the operating system and the running environment. Then what the company has to provide is the data and the application. So for software as a service, everything is provided by the cloud service provider. You get a finished product. That's all.
All right, thank you so much. That was also detailed. Thank you so much. Now, let us also look at this quiz and you tell me what you think. Which of the following services offered by Huawei Cloud, public cloud, falls into the category of software as a service services? You could go ahead and, some of you could go ahead and post into the chat. Someone is playing. Okay, so Maxwell, I've seen your answers. Right. Okay, so I see many of you are getting it correct. And you're saying it is facial recognition. Okay. So if I also rephrase the question and I said instead of software as a service, and I say which of these fall into the category of infrastructure as a service, what would be your answers? Hey, someone, Joseph, you said A on the first question. Why? Or could I get someone speak to me and tell me? Someone, you could just try. Yes, go
Hello.
ahead. Yes, Kasule.
Hey, sorry, it was a typing mistake. It was just
Hey,
fast.
it's okay, it's okay.
But
You want to tell us about
okay.
this question on the screen?
On the screen. A minute, I'm using a phone. It's disturbing a bit.
Okay. But anyone, try it out. I've just changed, removed software as a service, and I'm saying if the question was asking for infrastructure as a service, what would your answer be?
It would be A.
It would be A.
Yes.
Okay. All right. So just think about this. This is just elastic volume services. Okay. It is just infrastructure, still object storage services. There's no any kind of middleware or operating system or anything installed on it, isn't it? So still that is infrastructure, and also still since it's a server, nothing installed on it, still that would also still be infrastructure as a service. I hope that is okay, right? Okay, let us try and look at this question down here. The measurable service characteristic of cloud computing means that the users pay for how long and how much they use the cloud service. Is that true or is that false? Can I get a volunteer? I see Precious, your hand is up. Or Joanne. Any of you can.
It's false.
Precious, can we?
The answer is B.
Oh, okay. Why? Joanne.
Okay, based on the public cloud deployment model.
Okay. Joanne here is saying the answer is B. Could someone else tell us what they think? Yes, Precious, what do you think?
Yeah. For me, what I'm suggesting, the answer is A.
For you are saying
because
answer is
you pay depending on what service you are requesting on the cloud.
Okay.
Yeah.
You pay depending on what services you want on the cloud.
You want on the cloud.
I can hear you. Yes, Tito. I can see Tito. Thank you, Precious, for that. Yes, Tito, speak to us. What do you think? Okay, Tito is quiet. Any of Walter, Friday, Milliam?
Hi, I'm sorry, my
Yes, speaker was out. Okay, it's okay. You can go ahead and speak to us. What do you think?
speaker was off. Saying the answer is A, because we are looking at measurable service characteristics. That means you have to pay for that which you are going to use.
Okay.
On the cloud, yeah.
All right.
not paying for all, but for that what you're actually going to consume or use from the cloud.
All right. Thank you, Tito,
Yeah.
for that submission. Yes, Walter.
You're welcome.
Friday.
You're welcome.
I think that the answer is true, because for measurable service, you pay for what you have used. Just like a water bill, you pay for what you have used, not what you plan on using. So I think it's true, because
I think package.
you pay for what you have consumed within the period of time.
Okay,
Thank
Walter
you.
says also A. Right, Judith. Let me take Judith and
Hello.
Zara, then we wind up
Hello.
that. Yes, please. We can hear you.
This is Friday. I say the answer is false, simply because when I recall when you were talking about the advantages of cloud computing, you talked about measured service. And when you talked about this point of measured service, you said it provides a metering capability. It's not billing, but it determines the billing. So it does not mean that they are billing, but it provides the metering service. I think that's what I can say. You talked about it doesn't mean that this is the amount you're supposed to pay, but there is that capability, actually an advantage to see how much you're using cloud, but doesn't mean that maybe you're being supposed to pay such and such an amount.
Okay. Thank you.
I submit.
Thank you, Friday, for that submission. Yes, Joan, I see your hand is up. You wanted to add on your earlier submission?
Yes, I wanted to give the why part, why it is false. When we go to the measure services as a characteristic of cloud compute, you said that you talked about metering, whereby you said metering is not billing.
Okay.
That means that's it. Metering is not billing.
All right. Thank you so much, Joan, and everyone for the submission. Guys, I want us to now remember what we said. And let us first look at this question critically. Sometimes it is important before you answer, you first try to understand the question. So they are saying the measurable service characteristic of cloud computing means that users pay for how long and how much they use the cloud service. But the definition, is this the definition of measured service? Of measurable service characteristics of cloud computing? I don't know. I don't know if you're getting me, okay? So this means, I remember and I emphasized and I said that measurable service is how cloud systems control a user or tenant's usage of resources by leveraging a metering capability. They are just measuring, they're leveraging a metering capability. And I remember I also said metering is not billing. Although when they are going to bill you now to determine that you must pay for how long and how much you use, they use this service or they use this characteristic, isn't it? I hope you have now got it. So the answer here would be false, because ideally measurable service characteristic of cloud computing does not mean it is actually the metering capability. Okay, but metering is not billing, although they can use metering to bill you, but it does not necessarily mean that whenever they meter you, they have billed you. Okay, so we have described what cloud computing is. Also, we have gone through the brief history of cloud computing. We have listed a few use cases of cloud computing and also described the characteristic of cloud computing. So that brings us to the end of the first chapter for today's class. And that brings us to the end of the first chapter of today's class. And now I am just going to write briefly before I close the class. I'm just going to take you through of how you're going to be the assignments and how you're going to be able to do them. So I'm going to share the link, and I assume for those who have not been part of my classes or some of the fellow instructors, I assume you don't have an account there. So I will request that you actually go ahead and sign up. You go ahead and sign up and do the assignments. Let me share with you the links now. I'm doing that in a few. Just a moment.
Hey, Sam, I think there should be a Q&A session because Kwesiga is dying to ask questions.
Okay, Kwesiga, his hand has been up and I thought I talked to him. But yes, Kwesiga, you can go ahead and ask.
Yeah, thank you. I think that previous question has caught everyone's mind, and I see we have mixed answers even irrespective of your submission on the explanation, because your submission still was very clear in your lecture. So I was given a scenario maybe to elaborate more and better,
okay,
so that we leave everything and imagine if you're taking an option of taking a cloud service which has 1 core maybe of CPU and 4 GB of RAM and maybe 20 GB of hard disk, and maybe they are charging you $10 per month. And let's say in that month, after you accepting it, you end up utilizing 1 core of CPU, but 1 GB of RAM and maybe 5 GB of hard disk. It mean that you're going to pay less than what you subscribe, or you pay the same? Because such scenarios will inform people very well to understand what a measured service is.
I didn't get your question again.
I said that I want to share a scenario which will maybe
you can go
elaborate
ahead.
more on what that question was leading to, because I see there is mixed reaction whether it's false or true.
All right, that's
and
okay.
with the background of saying measured service doesn't mean billing. So I'm sharing the scenario that imagine whereby you're procuring a virtual server, whereby you're considering 1 core, 1 CPU, 2 GB RAM, and maybe 20 GB hard drive, and they are selling maybe $10 per month. But it happens that after your subscription, you use 1 core, 1 GB of RAM, and maybe 5 GB of hard disk. Does it mean you are going to maintain and pay the other subscription of 10, or they will use that, what you have used, to bill you? Because maybe that's where people are getting mixed up from, and that can explain better by you answering that scenario.
The scenario of them billing you based on what you used, right?
Yes, than what you subscribed for.
Yes. So they just bill you basing on what you have actually used. Or sometimes it depends on the arrangement of the service provider. Like, for example, the people who pay the premium packages, okay? They're going to go and let's say, for example, Office 365, they pay for a premium package. And regardless of whether they're going to use 1 TB or 2 TB, as long as they're paid for a premium package, they can actually access all the platforms. But I think also the best scenario is, do you all have National Water and Sewage Corporation at your places? Could someone please respond?
Yeah, we do.
Yes,
No.
you do. Yes. Do you believe that there's some kind of metering capability installed somewhere? the measured service to measure how much you have used. And
Actually, I wanted to use that that scenario. Like they only bring a bill once a month, but
yes,
throughout that time at the meter is always counting. It's always measuring the amount of water you're using.
Yes.
So it's a similar thing. That is the capability of the measurement characteristic of cloud computing, the way I understand it.
Exactly.
Okay.
Even if you're not being billed at that time, the measuring capability is still going on.
So Daniel and Sam, here's my 2 cents of the whole thing. I believe the billing is not limited to a certain. Actually, I had even brought this earlier on, that it's not one mode of payment. For instance, if you want infrastructure, let's say you just need a box, and then you subscribe for an instance on the cloud, it would be better to go for postpaid, whereby you subscribe and they bill you on what you have used. That would mean if I have an account with $500 and then I happen to have used, let's say 10 or 1 GB, which is like 10. Okay, it's not the right one, but I'm just using an example. They would bill for that 1 GB. That is if I'm using if I'm using infrastructure. But for software as a service, let's say 360, it's different, whereby depending on the usage, it is a flat figure. So we have here National Water and we have Yaka. You understand? Yeah, Yaka, what I pay for and I use, I will still remain with my what? I will still remain with my tokens. But then National Water, there is nothing like I've bought these tokens and then they will still be counting on what I've paid for. National Water will just read the meter and then charge me for what I've used. But for Yaka, I'll have to use and have credit, but then I keep on reducing on that credit. I'm believing it's ringing a bell somehow.
Yes, yes it is. Ideally, what you should look at the back of your head before even you think of anything else.
Hello?
The metering capability, what is metering? Before even you think of charging, it is the ability for you or them to know how much you have used, isn't it? And how long you have used, or what are you planning to use? That is the measuring service. Like he has said.
In other words, it's just for auditing.
Yes, for measuring. Actually, let us use the word in its sense. It is just for measuring.
It's an ongoing thing.
Yes, for
unlike
measuring.
unlike the billing. So
you realize, let's say Google Drive or OneDrive, they give you free tiers. Or even if you go to Amazon or even Google platform or Microsoft Azure, they are free tiers, right? Which you can use freely. But still, the measuring capability is there. It will be able to show you that you are going to use, let's say, 1 GB or 500 MBs of the hard disk. You're going to use 1 CPU, they're already measuring. And they will show you that your server has been running for this time and this time. After this time, you can't use it any longer. So they're already measuring, but they have not billed you any single coin. I hope that also throws some more light. So measuring in its sense is not necessarily billing. However, when you're billing, of course, you need to have a basis on how are you going to bill someone. You need to know how much have they used and for how long have they used it, then you're able to bill them. Okay, so anyone else?
The links?
The links, okay, yes. Now I'm sharing it now. I'm sharing it now.
Hello.
Yes, please.
Good afternoon, Cindy.
Good afternoon to you.
Yes, Precious here again.
Yes.
Yeah, good evening. Good
evening to you.
Yeah, I was liking. Yeah, I understand. I was likely to understand about the under service.
You are somehow breaking.
As I was asking, can you hear me now?
Yes, I can hear you now.
Yeah, I was asking about security as a service. Is it under service as?
Yeah, you're asking about what?
About security as a service.
Security as a service.
Because in the models of cloud computing, there were only PAS, IAS, and HAS, which is service. Where is the security? Is it under HAS?
And what?
It's a service as a service.
Software as a service.
Software as a service.
Yes.
Where can we put security as a service?
Security as a service. Now you look and by the way, there are so many other service models, but those are the widely recognized services that all the major key players are offering. Okay. You also find other service models. For example, database as a service, DAS. You get it? So it entirely depends.
Yes,
but you understand what that service is all about, and usually the name will just try and describe for you where that particular
where that particular thing is.
Yes.
Okay. I thought they are only those limited ones.
No, they're not
cloud
limited.
service.
They're not limited, but those are the major, those are the ones which have thrived over time, which have been there and widely recognized.
Okay.
Yes, please. So I am sharing the links now.
Okay.
And I want you to go and try out those courses. The data assignment tonight and tomorrow, so that we get some time to get feedback in the coming lecture. So I'm posting in the group now. That is the link to the. Have you received it?
Yes.
Yes. I received it.
You've received
Sandy,
it.
I wanted to say something. I wanted to say something in line with security with what our colleague has asked.
Yes, you can go ahead. No worries.
Yeah, I wanted to emphasize that also security can fall under software as a service. For instance, Cisco has been selling firewall, on-prem firewalls for a long time, but nowadays they have what they call Cisco Umbrella, whereby everything, all your traffic, you can control it from the cloud. So they give you software as a service, whereby it has no difference by having a physical firewall at your premise.
True. True. So I'm sharing my screen now. Thank you so much for that submission. So I'm sharing my screen now. And when you go to that link, it will take you to this site. I believe you can see my screen, can you?
Yes.
And I will assume that you don't have an account as yet. So you click, it will take you to this link. So you click on create an account. When you click on create an account, the things which are marked with red, it means that they are required. So you just put in your username, the password, make sure you don't forget the password, your email address, and the email address again. For example, in this scenario, let me just put in, say HCIA, username, I call it HCIA. And then I go and set up a password, and I, which one? Now, okay, let me just leave that. I say HCIA, you put in a password which is strong, and it must have at least 8 characters, contain 1 digit, at least 1 lowercase, and this is a standard password, required minimum password policy. So you just follow those and make sure you come up with a password like that, and you put in your email address. Let me use this info@sendyes.com. Then put in the email again. Put in the email again, then put in your names. Put in both your names. Put in your names, and now these other ones are optional. You can either choose to fill them in or leave them. And then you say, create my account. So after that, they will tell you that an email should have been sent to your address, info at the address you have provided. It contains easy instruction to complete your registration. So kindly, if you have difficulties, contact the administrator, but because I assume I'm teaching cloud engineers, I hope you won't have difficulties. So you go to your email. After going to your email, your mailbox, okay, just a moment. Okay, so as you have seen, in my email box, I've already received the email. Are you all seeing? Sometimes if you can't see it in your email box, you can check the spam folder.
You can see.
All right, you can check the spam folder or the junk folders. Sometimes, depending on the configuration of your email account. But in most cases, it will be in the inbox. If you can't find it in the inbox, you check in the junk or spam folder. Usually, unless when you have provided a wrong email, but you should be able to receive this email telling you, hi, so-and-so, a new account has been registered on this management system. Do you want to continue? So you just click on this link, right? I'm not going to click on it because I don't want it to open in my default browser. So let me just copy it and paste it here. But you just click on it and it will open in the browser. So after you clicking on it and opening in a browser, it will take you, it will tell you, it would actually take you to the portal you have signed in, and it will tell you, thanks, so and so, your registration has been confirmed, and then you press continue. When you press continue, you'll see these courses available. Ignore this one for now, and then you come to cloud computing here, okay? Cloud computing, and when you see cloud computing, you say access. You say you want to gain access. When you say you want to gain access, there is enrollment. They're actually asking you for the enrollment key. Yes? And I prefer you choose self-enrollment. Okay? You choose self-enrollment, but they're asking you for the enrollment key. Okay? So you look out for the enrollment key, which I'm going to share. Let me try and look for it just shortly. So you look out for the enrollment key. I'm going to be sharing it just briefly. Just a moment, I'm going to be sharing it with you. I am
Abang.
the key. Hey, yes, Sebo. I'm just generating the key, then we are good to go. I'm around. But I hope you're all okay. Just getting the enrollment key. Okay, so let me share this. Okay, I'm sharing it now. No. No. Okay, so I'm going to post the key in the chat.
That's better.
Yes, I'm posting it in the chat. That is the key, okay? So let me share my screen and we wind up. So when you get this here, you are all seeing my screen. You put in the key, which is HCIA at 0920, and then you say, enroll me. Are we together?
Yes.
Oh,
Yes, please.
was incorrect. Wait, let me see. Okay, so
It says enrollment.
no, sorry about that. So what you do, instead of selecting self-enrollment, you just say the first box, you select enrollment, that cloud computing code, not self-enrollment. The first one, that's where you post the code. Sorry about
The
that.
student one.
Yes, the student one. The very first box, So when
student/cloud computing 4.0.
Yes, that one. So you enroll and you put in the key and say enroll. So when you're done, it's going to take you to this page. Are you seeing this page?
Yes, please.
Yeah, so when you see this page, we have
Yes.
2 assignments, and your task is to at least attempt this assignment here. So what you do to attempt it, you click on it, and when you click on it, it will load, and it will tell you that this quiz is open. You can ignore the dates. We'll change those things later. It has 55 minutes, and we are attempting using the highest grade. Then you say attempt quiz. Are you sure you want to start attempt? Then you say attempt quiz. And then the questions will come there. Let me see. At least try as much to answer the ones that have been, because this one has also virtualization and also the first chapter, but you can go ahead and try and answer the questions that we have gone through. Okay. All right. But try them out. I need you to try them out. It is for your own benefit. You will thank me later. But as of now, that is it. And keep in mind, I can be able to track who has done what.
Should we do it before? Should we do it before tomorrow's class?
Yes, that would be better, because when you meet challenges, you can even be discussing in that forum on the channel as you can be, because you can be expounding more on those questions and getting answers to them. The earlier you do that, the better for you. All right.
So what if the pass mark is below 80?
No, you try it.
Is just...
For now, it's a first lecture for now. So I will go ahead and even change the pass marks. But for now, you can go ahead and try it out. Don't mind about the pass marks, but to try it out and to see how. Actually, you can even try both of them out and see how you're going to perform.
Mr. Sandy, how are you?
I'm okay. How are you?
Precious here.
Yes, Precious.
So these quizzes, are they redoable? Like, for example, is there a scale of like if you fail the quizzes or something like that?
Yes, they are redoable.
For example, I've looked at...
They are redoable. Okay. They are redoable, and you see, even if you have logged out and you log in, as long as your time has not yet expired. You see now this one, I moved away from the page, and it is saying it is in progress. Yes. So if I continue,
okay,
I will find my 55 minutes. I would have used like about, you say I have 52 minutes left. So the system is designed in a way that can enable you, even if you can actually even switch devices and go on another device, and you can still continue working as long as this time. When this time elapses, it will automatically submit itself.
Okay.
Yes,
that's cool.
Submit. But then let me finish the attempt and I show you. Even when you finish the attempt, I will show you these have not yet answered, and submit all and finish. Are you sure you want to submit? Yes, I want to submit. So when you go ahead and submit, you see that I've failed all of them because I've not answered them. To even show you, I didn't want really to show you some of the things. But after then, let me go back to finish review. Let me go back here. You see that I have an option to reattempt. Yes, I have an option to reattempt it. So I can go ahead and reattempt it. Okay, to even tell you the performance is below average.
Okay, so Mr. Sandy.
Yes, please.
What are, depending on how we do these quizzes, these quizzes, do they affect our performance?
No. The ones which affect your performance, I would definitely tell you. But it affects your performance in reality, because if you don't do them, then you won't be familiar with how Huawei sets its questions, and you won't be familiar, or you won't be able to translate what you have covered in class to be able to answer those questions. So actually they benefit you because you get an opportunity, you have acquired knowledge, but now you are seeing actually if you can refer to the knowledge you acquired in class. So
Okay.
the affect you, I'll clearly make it very clear that please do this, because if you don't get this pass mark, you won't be able to get the voucher. I'll communicate clearly.
And something else I've noticed with this class. Yes, it's like almost 4 hours.
It's supposed to be 4 hours, but I'm planning.
Is this something that's going to be happening all the time? Like, yeah.
No, as you noticed.
What I was asking is this something that's going to be happening every class of sharing ideas?
Of sharing ideas? What kind of ideas are you talking about? Like me?
Like what we are doing right now, for example.
No, not really. This is the first session.
Like, for example. Okay.
Yeah, this is the first session, so I had to demonstrate and show you how you do this. But I plan to use strictly 3 hours. If you noticed, I finished the chapter by like 8:30. But remember, we had introductions and all that, and brief introduction, introducing people to the course. So, but I intend to use 3 hours. I'm supposed to use 4 hours every day, but I intend to use 3 of them. And I also advise each and every one of you, when you get time, go through the material. It's readily available for you. Just read through it and try to, understand what is happening. Even try to do more research beyond the material that is available and discuss with your peers. There's no better learning mechanism than discussing, challenging. Right. So,
thank you very much.
All right, allow me to end the class now. Thank you so much. Thank you all of you for being part of this class. See you tomorrow. I hope you have all taken the attendance. The attendance are very important for all of us. So kindly make sure you take attendances every day. Precious, you have something to say before I end the class? Because